Hello, we are Stella,
Helen,
and Paulien, and thank you for joining us while we discover the answer to the question, how much does a blade of a windmill have to weigh to maximize the energy output?
our standard variables will be the weight of the windmill without bladed, 8.3 grams. Distance between fan and windmill, 15 centimetres. Amount of wind out of the fan, 3. Fan type, wind 36. Same distance between each blade, 7 centimetres.
our independent variable will be the weight of the blades.
And finally, our dependent variables will be the amount of energy produced.
Now let's see what is needed to start this experiment.
Firstly, cut out as many cotton papers as you can. Cardboard, sorry. A weighing scale, Data Logger Pro, which you will then eventually plug into your computer. 3 pins, blue tack, a retort stand, a fan, and a turbine, and of course tape and scissors.
The procedure goes as following. First, you take 3 paper clips and shake them like this.
Then you stick them into the cork in order for them to stay in place. Use blue tack around the paper clips like this.
Plug in your Data Logger Pro and open up the program, which looks like this. So make sure that each paper that you cut out is the same weight. So I'll make them 0.7 grams, as I can show you now, or close to 0.7, as you can see. And this one is also close to 0.7, or is 0.7. I suggest you cut out about 15 to 20 pieces, just to have enough.
Okay, once you've completed this step, record the weight of one blade and then use blue tack to attach the pieces of paper clips like this.
Place your windmill on
So do this for all the ones. And so once again, just make sure that they're all a little bit distributed. And here you go.
Place your windmill on the retort stand. Make sure that the height is always the same. For us, the height is 30 centimetres. Also make sure that the distance between the fan and the retort stand is the same. For us, the distance is 15 centimetres.
Plug in your Data Logger Pro and open the program. And attach the black and red to the turbine, as you can see these little things. And it doesn't matter which side you plug them in, they're both the same. So here, it's very hard sometimes because they're very small. But here, just around there.
Now you're ready to turn on your fan. Sometimes the blades need a little push to start. And if even a little push doesn't help, readjust them.
So here you can see that I didn't stick them on properly, so I'm going to take my tape. So if we turn off the fan, I'm going to take my tape and just secure it even more, like this. Because sometimes the blue tack doesn't like staying in place. So do this, and make sure that, once again, it's very important that they're, very spread apart and have the same amount of distance between them. Okay, now let's turn on the fan again and try it again. Make sure that everything is back in its place. So the retort stand has to be there. The plugs should be back in. The fan, everything is good. Okay. And then also press collect on your signs.
To make this experiment as exact as possible, redo this procedure 2 more times and find the average. Now take off all the blades,
Of course.
all papers, and with masking tape attach another paper. Do the same to all other blades. How much does one of these weigh? Record it.
Now, stick the cork back into the turbine and place it back onto the retort stand. Make sure everything is in the right.
Including the red and black plugs. So you need to repeat steps 7 and 6, which are to weigh the cardboard papers and stick them on with blue tack or tape, whichever one is better. Preferably tape, because as you saw before, that was much better.
Okay, well, these are our results.
What was your conclusion? Our conclusions were that we came up with the heavier the blades. So wait, as you can see, I will open it. Here are our conclusions. The highest weight we got with the most energy output was 8.7. So that proves. And the energy output of that was 135.
What were the errors?
Well, now that you ask, there are quite a few errors that we made in this particular experiment.
The blades may not have been the same weight.
When we rebuild the experiment, it might have been slightly different than when we made it the first time.
The fan we used for the wind was not standing in the same place all the time.
We also had to write down all the scores, and we may have made a typo of some sort with the numbers.
Also, when we had two times the speed and everything, there might have been an inconvenience there.
There are some. These are some of the most relevant mistakes that happened whilst we conducted our experiment, but obviously there were also some minor details. Correcting all these errors would have improved the accuracy of our experiment.
For example, weighing all the blades, double-checking that everything is in the right position, such as the distance between the fan and the windmill.
Thank you and have a nice day.